environment in general rather than specifically. I think, though it's difficult to tell because a lot of the 60s episodes are missing, but I think that's the first time we see the disk of the Earth in its totality in Doctor Who. And it's using material that had been in the news and was in the culture at the time. And that's something that Doctor Who does a lot. But in terms of space and in terms of astronomy, it's something that this year of Doctor Who does a lot. So the stories later in The Ambassadors of Death, the Doctor goes to Mars on a space rocket, because this is a few years ahead of where the space program is in real life. But the way that story is told is it's all told from mission control, and you have Michael Wisher, who later played Davros, playing a newsreader who reads an auto cue, giving you updates on what's happening, which is exactly how the space program, that's how the bulletins before Doctor Who would have told you what's happening with Apollo 12. And there's a cliffhanger in Ambassadors of Death, where the Doctor goes off to Mars, and the cliffhanger is something goes wrong with the rocket and they lose contact with it. And that was broadcast on a Saturday, and on the Tuesday, Apollo 13 in space had a problem and had exactly the same issue. And if you compare the footage of the Ambassadors of Death, where the people in mission control are going, we've lost contact and we're not sure what's happening, to the news footage of Apollo 13, it's weirdly set, it's framed the same way. The way the newsreader stands with the mission control behind it is exactly the same. So all of those things are feeding into the story. Whereas when you get a couple of years later, after the moon missions are finished in December 1972, the following year you get John Pertwee going into space in Frontier in Space, and it's much more science fiction. It's much more, he goes out and they press a button and they fly several light years in an instant. And that's because suddenly you've not got the culture of going into space. The reality of space travel is no longer something we're dealing with every day. So you can see in Doctor Who, watching old Doctor Who, it reflecting the science and our understanding and our sense of science. And my favourite example of this is that to show how our sense of technology has changed over the years, in the 1960s, 70s and 80s, generally in Doctor Who, computers are bad. There's a 1968 story, The Invasion, where the Doctor's companion Zoe goes into Millbank in London, which is obviously the offices being run by the Cybermen, and they have a computer receptionist. And for no reason at all, Zoe ties the computer up in logic until it breaks down, just because it's a computer and therefore bad. There's a story that I love from the late 1980s called Curse of Fenric, in which using a computer to crack codes is going to enable vampires from the future to take over the Earth. When Doctor Who came back in 2005, our assumptions about technology had changed. In the second episode, when it came back, Doctor Who did something really important. He takes Rose Tyler's phone and affects it so that she can call home from the end of the universe. Because the idea of travelling in time and space with the Doctor and having these fantastic adventures, but your phone not working, was too horrifying. So in the 16 years between Doctor Who coming off the air in 1989 and coming back in 2005, our assumptions and our sense of ourselves and our relationship with technology has completely flipped.
So I think the point that we're trying to make here is that Doctor Who has always kind of grounded itself in our understanding of science at the time at which the series is being made. And there are lots and lots of different examples of that. Do we want to go on to the next bit?
Yeah.
Right.
Available to buy on DVD. And some of it's available on BBC Scotland for Blu-ray. Can you explain the science of what we see?
Well, there's lots to talk about with this bit, and this is one story that Simon and I had lots of discussions and debates about, most of which Simon won. More of that in a moment. However, just to start off with, so this story is set in 2049, but I think it reflects very much where we are right now, or at least certainly where we were in 2014, and I think where we still are now in terms of our attitudes to space travel. So in that first clip in the 1970s, that was right in the middle of the Apollo moon program. So human beings were actually going into space, they were actually going to the moon while those stories were being made, while those stories were being shown. Now, I work at the Royal Observatory in Greenwich. We have hundreds of people coming in every day. They all want to find out about space, about astronomy. But one thing that people seem to have in their heads is that we've sort of given up on travelling into space. We had the Apollo missions nearly half a century ago, and really now, well, we sent Tim Peake up to the space station, but that's just a few hundred kilometres up. we haven't really sent people any further than that for 50 years, which is true. And so we've kind of given up on space. Why have we given up on space? That's what people want to know. Now, this story, which is set in 2049, in the story, the scenario is that in 2049, human beings have basically given up on going to space. They've sort of given up. They had to get that space shuttle out of the museum because they don't really have the technology around. They've sort of forgotten about space as a place that they should go to. So although it says in 2049, it's very much riffing off that kind of attitudes towards space at the moment. Now, of course, that's not true. We do have lots of exciting plans to send people back to the moon, to asteroids, even onto Mars. So watch this space. But Doctor Who is very, very cleverly picking up on the kind of the zeitgeist at the moment about what our attitude towards space really is. However, there's also lots of science to talk about in the story. Has everybody seen Kill the Moon? Who hasn't seen it? One or two. I'll try not to give you any big spoilers.
But I told them the moon is an egg with a dragon in it.
Right, okay. I won't tell you that. So, the discussion that Simon and I have had about the story, I love this story. I think it was tense and exciting, and then at the end, it turns out what he said. And I was really disappointed because for me, that wasn't science fiction. That was too much fantasy. But as we talked about the story, Simon convinced me that there was a lot of science in there. So we've already said about how it's really picking up on this attitude that human beings, right now, we've given up on sending people out into the galaxy. But also, there's lots of science in that clip that we just saw. So one of the things that I really like about Doctor Who is the fact that the Doctor is a scientist. And I think, for me, that was one of the things, growing up watching Doctor Who, that made me understand what a scientist is and what science is all about. Doctor Who is peppered with scenes where the Doctor explains what it means to be a scientist. He tells Leela that science is not about just taking things as read. It's about asking questions. It's about exploring the world. It's about looking at evidence and piecing it together. And sometimes your assumptions about the way things are turn out to be wrong, and you have to accept that, and you have to change and update your views. And there's a great line that I think we have on the back cover of the book somewhere, where Leela basically tells another character who is a bit superstitious. She says, "I too used to believe in magic, but the Doctor has taught me about science. It's better to believe in science." And I think all these sorts of things came together to help me understand what being a scientist was. There's another line that Tom Baker has where he's arguing with a scientist who is not behaving particularly well. He's taking some risks. He's putting other people at risk, and he's doing some quite dangerous things. This is in Planet of Evil, and he says, "You and I are scientists. We buy our right to experiment with total responsibility. In other words, if you're going to do something, you have to make sure that you're responsible for what happens and that it's not going to harm other people," which is, I think, a very important part of what being a good scientist is all about. So all of those things come through in Doctor Who, and right at the beginning of this episode, we see the TARDIS land. They think they're going to land on the moon, they've got their spacesuits on, they step outside, they're not on the moon. Where are they? And instantly the Doctor starts being a scientist. He starts trying to work it out using the evidence around him, and he works out not only that they're in a space shuttle, but it's 2049, judging by the prototype versions of them, it oscillates. Did I get that right? From Ark in Space.
Very good.
Thank you.
I've been teaching.
We should say, actually, when Simon and I first started working together, Simon used to use me as a scientific advisor, a bit like the third Doctor was for UNIT. And he kept asking me questions, phoning me, emailing me. And eventually I sort of said to him, "Do you know what, Simon? I think we should do astronomy GCSE, which we run at the Royal Observatory." Not because I think you're dumb, but just because if you knew a bit more astronomy, you would ask more interesting questions.
It's not quite how
it was a bit like that first clip, actually, with Simon kind of sweating at the keyboard and me coming in saying, "What is it?" Anyway, Simon did do astronomy GCSE and he got an A-star grade, so he does now ask much more. Yes, he does ask much more interesting questions, I'm happy to say. However, during this process, I discovered that I know a quite shocking amount of Doctor Who trivia as well, so we sort of kind of moved into each other. Back to the clip. So we see the Doctor being a scientist, he's pulling in bits of evidence and putting them together to work out what's going on. Classic science, that's how we do science. It's all about evidence, not about your preconceptions, it's about getting rid of those and looking at what you can see around you and using logic and reason to put them together. Now, there's another bit in that clip. Do you remember the bit where the TARDIS is kind of flying towards the moon? And you saw the moon kind of spinning in the background. Now, I got very annoyed about that because, as I'm sure you all know, the moon does spin on its axis, but it spins once per month. And that's why it always keeps the same side facing towards us, because as it orbits the Earth, it also spins at exactly the same rate. So it's always got the same face towards us. So you would never see the moon spinning in real time like that, because it takes a month to spin all the way around. And I was saying to Simon, they got it wrong, what's going on? And Simon said,
TARDIS, you may have picked this up if you watched the video, TARDIS actually travels in time. So what you're watching is time travel happening in front of you. And this is our thing.
Absolutely. There's another thing in this clip, again, which Simon picked up on, which is to do with the airlock. So the Doctor runs to the door, there's a sign that says airlock, and he looks through, and Simon, explain the problem.
So the problem is that an airlock is a containment area that you can flush the air in and out of. But that's just a door with an airlock. If you open that door, you just fall out into space. So it's not an airlock. But we said this at another talk we gave, and a child said that the space shuttle is designed to hook up with the International Space Station. So it's where the airlock bit would attach. So it is so you can make these things work with a bit of thought. And this is what we've been finding quite interesting, that actually when people say the science is not right in Doctor Who, actually trying to figure out how it would work, or why it's wrong, or what the problems are, is actually, we find, quite interesting.
Very entertaining, and there's quite a lot of that in the book. And again, after Simon did this book with me, he wrote a book called Who Graphica, which is a great infographics book about Doctor Who. I highly recommend it. However, one thing that I was particularly pleased about in the book, Simon worked out the professions and backgrounds of all of the Doctor's companions, and it turns out that a whopping 1/3 come from backgrounds in science, technology, and medicine. So, if you are hoping one day that the TARDIS will materialise in a corner and the Doctor will, beckon you in, come and be my next companion, having a career in science, technology, or medicine is probably the best way to go. So, there you go. I'm still waiting.
Should we get people to ask questions?
Yes. So we've given you a bit of a lecture, but I think actually what's more fun is for you to ask us questions about science in Doctor Who. We are perfectly happy for you to ask the hardest questions you can think of. So if you want to know why is the TARDIS big on the inside, if you want to know how you can escape from the black hole, all of these things are easy. Very
harder
easy,
than that.
very easy. Go as hard as you like. Does anybody want to kick off? Yes.
Do you think the airlock principle might have been based on submarines when divers used to go through them?
So your question is the airlock principle based on divers?
Submarine naval divers.
Well, this is a very interesting thing about the space program, is that of course it's not all new technology. And yes, you're absolutely right. There's a lot of the technology that went into the space program for human spaceflight in the 1960s and 70s. You can trace a lot of that back to things like diving technology, submarines. It is much more like a submarine than an aircraft. So yeah, and in many ways, I work in Greenwich, which is famous for the observatory and the stars and space, but also it's a very maritime place. So we're very conscious of maritime history. And I think it's very true that when we do start going back into space, going to Mars, going to asteroids and things like that, those space journeys are not going to be like it's not going to be like flight, it's not going to be like flying in an aeroplane. It's going to be much more like going back 200 years to the great age of sailing ships exploring the world, where you're going away for months or years and you have to take everything with you, and you don't even know when you're going to come back. So it's going to be much more like sea travel sailing ships than it is going to be like.
I spoke to one of the Avery, the pilot, gets into the TARDIS and looks at the controls and can name what the controls are, because it's the same system, the same machine. And there's a bit of a fudge going on there, but it's a nice analogy. Another question. Hello, Ace.
Hello. I'd like to know what you think, how the time storm that Ace experienced, how that could got her from Earth to Leicester.
Excellent. So the question for those who you might not have heard is how did the time storm that we hear about in Dragonfire get Ace from Earth to Spartos, I think, maybe the planet of Dragonfire. Well, there's a number of things. First of all, Ace failed her chemistry exams, we know this, but she has a particular knack for explosives, and clearly has an early knack for explosives because she burned down a house in 1983, 6 years before being a doctor, and she blows up the Class 4C's pottery pig collection while she's at school, which is referred to as battlefield. So there's clearly some sort of interest in chemistry and explosives. And the person that I've talked to about this is Danny Hargreaves, who's the multiple award-winning guy in charge of explosions and what to do. He's better known in the trade as Danny Bang. And we were chatting about how when he's doing an explosion on the TARDIS set, his knowledge of chemistry and combustion physics is that he has to know what amount of explosion he can set up that Peter Capaldi can stand with next to it, so it looks really cool. And also, they've set the lights to be a bit pink in the TARDIS. So can he put something in the explosion that will also be pink, so it matches aesthetically? And so on a practical day-to-day basis, doing explosions, they have to think about that sort of thing, because that's how you do explosions. So Ace being able to do controlled explosions suggests, despite the chemistry exams, that she's actually very competent in that area. But also what we learned in Curse of Fenrir is that the time storm was created by what is effectively a sort of Cthulhu god called Fenrir to deliver her into the path of the Doctor. So there's a what doctors would refer to as an intervention there. But to cross space and time through an explosion, you're probably looking at something akin to a wormhole, a black hole?
Yes. So my physics answer. So Ace goes from the 1980s to the far future, and she goes from Earth to Spartos. So she's travelling not just through time, but also across a huge amount of space. Now, 101 years ago, Albert Einstein published his general theory of relativity, and it's still the theory that we use today to explain how the universe works. But it's full of really weird stuff, and one of the things that he says in the general theory of relativity is that you can't think of space and time as being separate. They are all part of the same kind of wibbly-wobbly, timey-wimey stuff, I suppose, that he calls space-time. So just to think about that, we have 3 dimensions of space that we can move around in freely. So I can move from side to side, I can move forwards, and I can move backwards, and I can move up and down, and also I can move through time. So now we're in a different time from when I first started talking. So we have those 4 dimensions that we can move around in. And actually Doctor Who, right from the start, was very much riffing off Einstein, because of course you all know what TARDIS stands for, right? Time and relative. Thank you very much. Which is basically the essence of general relativity. So I think the writers were very much drawing that together. So really what Einstein is saying is that if you want to travel through space, you have to move through time. So you can't do a journey without it taking some time. So any journey through space takes some time. But the flip side of that is that journeys through time presumably would involve some kind of journey through space. Of course, the TARDIS seems to be able to circumvent that sometimes. But if Ace is travelling in a rather kind of primitive, ad hoc way, then if she's going to travel a huge amount of time into the future, she's probably going to be thrown a huge amount of distance across the galaxy as well. So that's my explanation.
But my main concern about the physics of it is that it would take an awful lot of energy to do it.
Yes.
Which shows how powerful Fenrir is in being able to do it. But also, we know when Ace gets back to Earth and her old neighbourhood in Perivale with survival, and she bumps into her old mate Ange, who doesn't seem surprised to see Ace. So if there was this hugely powerful explosion, it didn't burn down a house, it didn't leave a mark that made the news. and thinks just went to Birmingham. So not only is it extremely powerful, but it doesn't leave a mark. The suggestion is that as far as everybody's concerned, Ace ran away. So it's an extremely powerful thing to do, but Fenric had such power that it didn't leave a mark when they left him. And that is, I have pitched actually to finish a thing about like what happened with Ace's gun. Did Ace find a note or just I've never known before. I think we've got time for one more question.
One more question. Okay. You pick someone.
There's a question back there. Hello.
In Aliens of London and World War III, the Slovene.
Sorry, can you-
sorry. In Aliens of London and World War III, the Slovene use a compression field to get into the skin suits. What would the science be in the compression field?
Right. This is a question about Aliens in London, which is we were asked to name our favourite episodes at the last thing we did, and Aliens in London is a particular favourite of mine. So the compression field, the compression suits that the Slovene use to get inside skin suits. What's the science of that, Marek?
It's always like this. Thank you, Simon. Thank you very much. Yes. So we can talk about pressure and volume. So as you're probably aware, you know, some types of matter you can squeeze, you can compress them, and other types you can't. So if you imagine Victorian ladies squeezing themselves into corsets to give them a really tiny, narrow waist, lots of health issues with that, don't try to hope. But what happens, of course, is that it all comes out somewhere else. So you can squeeze something and not other things. Gases you can squeeze up to a point, but what happens when you squeeze a gas or a liquid? Well, if you squeeze gas, is it heats up. So the smaller you make it, the higher the pressure becomes, and the greater the temperature. So I think when the Slovene are probably a bit squishy. We know that they have a different biochemistry from us because they really don't like acetic acid, vinegar. It basically dissolves them. So their biochemistry is quite different from ours. So I suspect their flesh is a lot more kind of squashy than ours. But what's happening is when you squeeze them into those suits to make them human-shaped, or a little bit more human-shaped, you're raising the temperature, and that's why there's a little bit of outgassing, shall we say? That's my explanation.
I wrote a book, a novel, the Phoenix version, and I had a lovely hour-long chat with Russell T. Davies about the mechanics of what the Slovene could and couldn't do. And although it's not said in a TV episode, so you might want to count this, you might not want to count this, but Russell's idea was that a human couldn't use their system. The skin suit system works because of the biology of the Slovene and that they're squishy, and as Matt was saying. So that a human couldn't take it and use it as a disguise. And he said that's partly for matters of good taste, because it means putting humans in a skin suit which is a bit grisly and that's something monsters do, it's not something humans do. But also he said that's because of the physics of it. And what you find talking to the writers often is that they thought these things through even if they haven't put it on the screen. But we are probably Marek and I are going to be around, so if you want to ask us questions.
Do come up and ask us your hardest science doctrine questions, and we do our very best to answer them. Thank you very much for coming. Enjoy the day.